Hey guys, welcome to another NLP video. Today we're looking at the paper Stronger Transformers for Neural Multi-Hop Question Generation by a bunch of authors from the Quebec AI Institute, McGill University, IBM, and ETH Zurich. So, as you may know, question answering models typically have relied on the squat dataset, where basically you're given a paragraph, for example, from a Wikipedia article, and a typical question is to recall a fact from that specific paragraph. Basically just picking information from that paragraph and returning it. So here we have some paragraphs, for example. Let's say sentence is Sir Brian Edmund Walker was a Canadian banker. A question could be, where is Sir Brian Walker from? That is quite an easy question, and of course we would like to extend this to move forward and go beyond such simple questions to more complicated questions that don't just require dealing with a single paragraph, but they might span multiple documents. And this is precisely the topic of the paper, where they deal with the problem of multi-hop question generation. The idea is basically you are given multiple paragraphs, in this case, about Sir Walker and about the University of Toronto, second document, for example. Could be multiple documents, 3, 4, 10. And then you are provided with an answer. And the task is to generate a question regarding the answer that spans multiple supporting facts from those 2 or more documents. One difficult such question could be, which Brian Edmund Walker founded institution was originally controlled by the Church of England? Which requires you to not only read the first or the second document, but the 2 together, multiple sentences, extract those sentences that are most important to come up with an answer. So how do the authors tackle this? They propose 2 new transformer models for this task. The first model is a standard transformer model with some modifications. But though that model is just taking all the documents as input, using some special encodings to make sure that the model can distinguish between the answer and the input documents. And then the model is generating the question in a sequence fashion. The second model is also integrating a graph and inputting that in addition to the text. This graph is basically based on entities extracted from the articles, for example, University of Toronto. And this graph is also applying some coreference resolution to link entities across those documents. For example, University of Toronto, let's say, could be linked to Research University, could be linked to institution, and so on and so forth. So this information is extracted using a entity named entity model and a coreference model, and is encoded and inputted as an additional input to the transformer model. So the authors discussed these models in detail in the paper, and they then perform some experiments, in particular trying to answer the question whether inputting this additional graph information is really needed, or whether some special variant of the transformer model can do the job on its own, because the transformer model in itself is also quite powerful, and it's able to, in theory, extract concepts in high-dimensional space, link them up, and also do the same job as this entity model. Hopefully it can do that. So moving on to some experiments presented in the paper. the authors use the hotpoint QA dataset, which is a recently proposed dataset for this multi-hop question generation. And there are two types of training approaches. The first is using only supporting facts extracted from those articles as input, and it's not working on the whole articles as a whole. This information is actually provided with the dataset as far as I'm aware. The second mode is to use the full documents as input. So taking documents, concatenating them, or using the special encoding mechanism, and then training the question generation model directly using those documents. The models proposed by the authors are the TE model here, which is the transformer encoder model, I think, and then the gate model, which is the model taking additional graph information as input. Basically, to sum up the main findings, it seems that first of all, the models trained on the full documents as input seem to be performing better than documents trained using supporting fact sentences only here, which is the standard way people have been using this hotpoint QA dataset in the past. The graph model and the text transformer encoder model seems to be performing quite similarly, which leaves us to question whether the additional graph input is really needed. Perhaps if we have an even more sophisticated transformer model, you might not really need it. So you might get away with just using a very strong transformer model, and then you don't need the additional input. And also the models are outperforming some previously reported baselines in the literature by a quite high margin, it seems. When it comes to some ablational studies that the authors perform on this gate model, it seems that a special contrastive training mechanism that they propose in this paper is quite important, resulting in 3 BLEU points improvement. Also, the authors propose a special method to filter the training data in this hotpoint QA dataset. Basically, they are filtering any pairs of articles and answers where the answers are longer than 30 words. It seems that answers that are longer than 30 words are particularly easy to generate questions about, so filtering those out seems to result in a stronger question generation model. And finally, their special approach to encoding the answer different from the input articles seems to be also pretty effective. So to sum up, authors propose 2 new models to multi-hop question generation. One just based on the standard transformer approach without doing any special inputs, basically inputting the text. And another one using an additional input based on, basically the input is a graph extracted from the entities of the articles. It seems that both are performing comparably, with the graph model having a small edge, but it's quite promising to see also that the transformer model without any extra graph information is able to perform quite well. And the authors also propose some various additional tweaks to those models that I didn't talk about in detail, such as a contrastive objective to identify the supporting facts and a special data filtering approach to produce a more balanced training and test dataset. Experiments show that the authors outperform the previously reported best approaches in literature by a substantial margin of over 5 BLEU points. So it's an interesting method, and I'm looking forward to see how far the MultiHop question generation will advance in the future. Thanks for watching, and please subscribe for some more upcoming NLP videos in the future.